Unit 7 Review, Question 18. Figure A and Figure B below are similar, and we are asked to find the lengths of the sides labeled little a and little b. So here are the sides, A and B, labeled on these two similar figures. So since we're told that these figures are similar, that means that there's a scale factor that exists to scale figure A to the size of figure B, and another scale factor to scale figure B to the size of figure A. And once we find that scale factor, we can use it and other given information to find the missing sides. So first, notice that in order to find these scale factors, you need to know a side for both figures, corresponding sides for the figures. So this side corresponds to this side, and we know both numbers, 20 and 12. These sides correspond, and we know both numbers. 8.2 corresponds to B, but we don't know what B is, and 9.6 corresponds to A, but we don't know what A is. So we have two options for finding the scale factors. Okay. We can either use these two sides, which I don't want to use because this has a decimal, or we can use 20 and 12, which I'd prefer to use. And notice our answers would be a little bit different. This is a rounded number, but we'd be close in either case. So let's look at 20 centimeters and 12 centimeters and find our scale factors. So up here, to connect this to the idea of how many times is large that we talked about in multiplicative reasoning in this unit, okay, figure A is 20 centimeters, figure B is 12 centimeters. So A is 20 over 12 times as large as B, and B is 12 over 20 times as large as A. Okay, how is this going to come into play with the scale factors? Okay. So the scale factor from figure A to figure B is, okay, so if you know a value in figure A and you want the value in figure B, you are actually going to write, you would multiply by 12 and divide by 20. So it is 12 over 20. Now this is the reverse when we found how many times as large as A compared to B, we actually wrote these in the reverse order. So I just want to bring that to your attention. What I look for is I'm noticing this is a bigger number, this is a smaller number. I'm scaling to something smaller, so that means I'm going to have a proper fraction. Okay, so I take the 20, if I divided it by 20, I'd get 1, and then I want to multiply by 12 to get the 12. Okay, so again, the scale factors through this process going one to the other are the reverse than when we talk about the multiplicative factor. Now here, to go from figure B to figure A, well, to get 20 from 12, I'd divide by 12. That would give me 1, so I put that in the denominator, and I multiply by 20. Okay. And again, what I usually do is I look at the two numbers. If I have a value here and I want to go to the bigger figure, I want to multiply by a number bigger than 1. So the numerator should be bigger than the denominator. So that's just another good way to double check. Okay, so now let's find these sides. So for side A, we want to start with the corresponding side in figure B, which is 9.6 centimeters. Okay. So we want to scale the figure B size to the figure A size. So again, I'm even noticing now A is bigger. Okay, I'm going from B to A, so I'm going to multiply by 20 over 12. Now let's compute that. So 9.6 times 20 over 12. And we get 16. So side A is 16, and notice we have our units here, centimeters. Note, I didn't simplify this. You don't really need to. You're just going to put it in the calculator anyway, so no need to simplify your ratios. Now let's find side B. Well, for side B, the corresponding side in side A is 8.2 centimeters. Now I am going to multiply by the appropriate scale factor. Well, to go from A to B, I'm going smaller, okay? We also know we found to scale from A to B, the B value is in the numerator, the A value is in the denominator. So we're going to multiply by 12 over 20. So 8.2 times 12 divided by 20, and that's 4.92 centimeters. Okay. And just as a last double check, I like to write my numbers in the figure. So A is 16 centimeters, B is 4.92 centimeters. Okay. And then I take one last look and notice 16 is bigger than 9.6, so I know I went in the right direction. Okay, doesn't mean my answer is right, even though it is, but I know that this should be larger, so I use the correct scale factor. And this was 8.2, and this is smaller, and again, this figure is smaller, so that seems to correspond.